Here's a tutorial review of the handout called Electron Arrangement in Neutral Atoms. If you ask a chemist why certain elements behave the way that they do and why they are found where they are on the periodic table, you'll probably get an answer similar to this one. It's really all about the electrons. So if you look at the element lithium, lithium has an atomic number of 3. So it has 3 protons in its nucleus. That also tells us that it has 3 total electrons, for now. Remember, this handout is called neutral Bohr models. So to make it neutral, there must be 3 protons and 3 electrons so that the net charge is equal to 0, or neutral. The atomic weight of lithium is 6.941, which we round to the nearest whole number, 7, and that's now the mass number. The mass number tells us the number of things in the nucleus. We know that 3 of those 7 things will be protons, therefore it has 4 neutrons. Now we give these shells names. This is the K shell, the L shell, the M shell, N, O, P, Q. The K shell, which is the first one, I'm not sure why it's called the K shell and not the A shell, but it does go alphabetically starting with K. The first shell, the K shell, holds 2 electrons and then it's full. The next one holds 8 and then it's full. And this one holds 8 and then it's full. Unless there's another shell out here, then it is possible for this M shell to hold up to 18. That's a bit complicated though. So we have 2 electrons that go into the K shell. 1, 2. Make sure you put your first one on the right. Your second one goes on the left. And then the L shell, which is the next shell out, will have that final electron. Now, because this electron is special, we call it a valence electron. How many shells did we use? We used 2. The K shell and the L shell. 2. What period is lithium in? 2. Interesting. This is period 1. And helium is way over here. Lithium is in period 2. Period 2, 2 electron rings. How many valence electrons? Well, it has 1. 1 valence electron. What group is it in? Group 1. What do you know? Group 1. The Lewis dot structure. You put the symbol, and then you just put a dot for the valence electron. There it is. Now if we go over here to oxygen, oxygen has 8 protons. If you round its atomic weight to the nearest whole number, you get 16. 16 minus 8 is 8. So it has 8 total electrons, 8 protons, 8 neutrons. Now what we remember from before is that 2 electrons can go in the K shell and that the other 6 have to go in the next shell out, the L shell. 2 in the K, 6 in the L. So we'll put 2 here, 1, 2, and now we have valence electrons. 3, 4, 5, 6, 7, 8 total electrons. Notice the pattern. 1, 2, 3, 4, 5, 6, 7, 8, and we put our 9th one there if we needed it, and our 10th would go there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now electrons are like people on a bus. they sit alone unless they have to pair up. You'll notice these two are alone. So one thing we do is we show that they're alone by putting in X's. Oxygen is in group 16. And we put X's in for all the elements in group 16. The number of valence electrons that oxygen has is 6. The number of shells that we used is 2. Going out of order here, sorry. And the period the element is in is also 2. Here's the dot structure for oxygen. 1, 2, 3, 4, 5, 6 valence electrons, and we'll put in our X's. Make these dots a little more prominent. So Lewis dot structures show the valence electrons, just the ones that are in the outer ring. And that's really all we need to know about. And you'll see why in weeks to come. Let's move on to fluorine. Fluorine has 9 protons. You do some fancy math with the rounding and the mass number, blah, blah, blah. You get 10. 9 total electrons if it has 9 protons. That means we have 2 in the K shell. And we're going to put the remaining 7 in the L shell. We're going to use 2 shells. Fluorine is in period 2. Here we go. 1, 2, 3. Oops, that should be green. 1, 2, 3, 4, 5, 6, 7, 8, 9, X. So you'll notice that we need to put an X here to show that this electron doesn't have a buddy. And fluorine is in group 17. Remember that oxygen was in group 16. So with group 16 and 17, we tend to put X's in to show those unpaired electrons. You don't need to put X's all over the place on lithium. So you would not put an X here and then 2 more there and 2 and 2. It would look too busy and too messy. So anyway, fluorine. Number of valence electrons, we have 7. The group the element is in is 17, cough, cough. It's also Roman numeral 7, so hopefully you see the connection there. And I'm going to put the symbol F, and here's its Lewis dot structure. 1, 2, 3, 4, 5, 6, 7, X. Notice that I didn't follow the pattern when I just put those dots around, because I knew that all of them would be paired up except that last one. But technically, I should have gone 1, 2, 3, 4, 5, 6, 7, X. So there's fluorine. So one thing to make a connection to at this point is that fluorine is here in group 17. That tells me that it has 7 valence electrons. Here they are, 1, 2, 3, 4, 5, 6, 7. The Lewis dot structure shows us that much more easily than the Bohr model does. At this point, it's easier to communicate certain ideas with the Lewis dot structures. Here's a cool thing. Every single one of these elements has a dot structure that looks like this. Argon. Argon is spiffy and special because it's a noble gas. It hangs out here in group 18, and it's down in period 3. So argon has 18 protons. It also happens to be coincidentally in group 18. And if we look closely at all the rounding and stuff, the atomic weight is 39.948, which rounds to 40. And 40 minus 18 tells us there are 22 neutrons. The total number of electrons for argon will be 18. That means we'll have 2 in the K shell. It looks like we're going to fill up the L shell with 8. That gives us 8 plus 2 is 10, and we have 8 left over. And those will go in the M shell. Looks like we're using 3 shells. And what do you know? Argon is in period 3. So we have 18 electrons to put around the atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 makes it full, 11, 12, 13, 14, 15, 16, 17, 18. Interesting. Argon has all of its shells filled, no X's anywhere. It has 8 valence electrons, it's in group 18, and it forms this nice, friendly, symmetrical Lewis dot structure, just like all the other noble gases. And wouldn't it be interesting to you that because this outer shell is filled, argon has certain interesting properties. It doesn't react with anything, and it hangs out all by itself, and this is mostly true for all of these other noble gases. So that's argon. Sodium. Sodium has 11 protons. It has 12 neutrons. This means it has 11 electrons. That means we're going to put 2 in the K. The L shell holds a maximum of 8. So there's 8. So we have 8 plus 2 is 10. And that means we have to put the final electron in the M shell. We're using 3 shells, and it's in period 3. Here it is. So it's in period, or row 3, it's in group 1. So here are the valence electrons. Here's the Bohr model with all the electrons. 1, we have 11 to put in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is the total number of electrons. It has 1 valence electron. It's in group 1. Its Lewis dot structure is that. Interesting. Lithium also has the same Lewis dot structure. And wouldn't it be coincidental that lithium and sodium are nearby each other? Let's do magnesium. Magnesium has 12 protons, has 12 neutrons, that's 12 total electrons, 2 in the K, 8 in the L, that makes a total of 10, and 2 more in the M. We've used 3 shells. It's in period 3. 1, 2, we have 12 electrons to put in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice the pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. So you repeat the pattern every time. Right to left, top to bottom, fill around, start over. Right to left, and then if you kept going top to bottom, fill around. And that's right to left, top to bottom, fill around. Okay, anyway. So we have 2 valence electrons. It's in group 2, magnesium. Dot structure looks like that. And now I will leave you with this thought. Magnesium is a metal. Oxygen is a non-metal. Magnesium has 2 valence electrons. Oxygen needs 2. These 2 elements can bond, and they will, but not at room temperature usually. You usually have to heat them up. And when they do bond, you get a new white powdery substance called magnesium oxide.